And finally, in this video, we have a third training exercise on algebraic expressions, factorizing, and solving rational forms. Here we have e of x equals to x minus 1 squared minus x into 4 minus 8x minus 4x squared plus 1, and here is f of x. Again and again we have to factorize each of e of x and f of x. And here is the other parts of the question that we are going to solve them one by one. Now, in part A, to factorize e of x as we usually do, we have to search if we have a common factor at first, then we search for applying identities, and after that, if none of these ideas work, we search of taking a grouping and other methods. So here, is there any common factor among these? It appears not to have any common factor, but here between 4 and 8 we have a common factor, which is 4. So e of x becomes 2x minus 1 squared minus 4x into 1 minus 2x, and we put parentheses along these two to have an identity, as you see here. So it will be 4x squared minus 1 in the middle, because a minus sign is outside, and whenever we put parentheses, we are going to change the sign inside. So this becomes a minus sign. Now we have 2x minus 1 squared. Here we have 1 minus 2x, and here is going to be separated into 2x minus 1 and 2x plus 1. Thus, I have to reverse 1 minus 2x to take it as a common factor. To reverse 1 minus 2x, we have to write it 2x minus 1, and we have to change this sign outside, as if we multiplied minus by minus to get plus. Now we take 2x minus 1 as a common factor. What remains inside is 2x minus 1 plus 4x minus this factor 2x plus 1. Introducing the minus sign, we get inside 2x minus 1 plus 4x minus 2x and minus 1. These two are opposites, so they cancel. So what remains inside is 4x minus 2. So we get that e of x equals to 2x minus 1 into 4x minus 2. We still have to take 2 as a common factor. We take it and we put it at the beginning. So we are going to have that e of x equals 2 into 2x minus 1 and 2x minus 1 again, so as if it is 2 into 2x minus 1 squared. That's the factorized form of e of x. What about f of x? F of x equals 4x cubed minus 4x squared plus x. So again, we search if we can take a common factor. Yes, we can. We can take x as a common factor. What remains inside is 4x squared minus 4x plus 1. What does that remind you of? It is an identity. It is 2x minus 1, all of it squared by taking the extremities. So 4x squared becomes 2x and 1 remains 1. And thus f of x equals to x into 2x minus 1 squared. Now we have here g of x that's equal to 2 into x minus 2x minus 1 squared, which is e of x over f of x. So the first question is to find the roots of f of x and then to deduce the domain of definition of g of x. To find the roots of f of x, here is f of x. We have that x into 2x minus 1 squared equals to 0. So to find the roots is to solve it equal to 0. Then either x is 0 or 2x minus 1 squared is 0. Then x is half, and we call it a double root. So to deduce the domain of definition of g of x, since f of x is in the denominator, then directly the domain of definition of g of x is all real numbers except the roots of the denominator, which are the roots of f of x. And thus d equals r minus 0 and half. So all real numbers except 0 and half. In part 3, we have to solve g of x equals 2 over x. So we have to simplify first of all g of x. To simplify g of x after the domain of definition, we have to cancel these together, and what remains is only 2 over x. So we have to solve g of x equals x, then 2 over x equals x. As usual, we put it over 1, we cross multiply, then we'll get x squared equals 2 times 1, which is 2. So x squared equals 2, then x equals plus or minus radical 2. Okay, if we have x squared equals 9, remember, then x equals 3 plus or minus 3. 3 comes from making radical to 9. Here, since 2 is not carried out of the radical, so we keep it in the radical, and the answer is plus or minus radical 2. Now, to evaluate g of minus half, all what we have to do is to replace x by minus half. So we'll get 2 over 1 over minus 2, or minus half. Here is the minus sign. So we can put 2 over 1, we can make this way, and thus we are going to get 2 times 2, which is 4 over minus 1, which is definitely minus 4. So g of minus half is minus 4. Now, what about the roots in this part? X is plus or minus radical 2. Are they accepted or rejected? Of course they are accepted, because we don't have here radical 2 among the excluded values. So these two values, plus or minus radical 2, are both accepted. And let's see now what we have in the last part. In the last part, we have to calculate a, b in this polynomial q of x if if q of x equals to f of x. So we have to find a and b if this polynomial q of x equals to f of x. So of course we are going to take the factorized form of f of x in order to make comparison. What do I mean by comparison? I mean that I look at the coefficient multiplied by x cubed here and the coefficient multiplied by x cubed in f of x. So I just put q of x and f of x, and I start comparing. The coefficient of x cubed here is a plus 2, and the coefficient of x cubed here is 4. Then directly I write a plus 2 equals 4. So a equals 4 minus 2, which is 2. Similarly for b, I look at the coefficient of x squared here, it is b, and the coefficient of x squared here is minus 4. So using comparison again, b equals minus 4. Hope you are going to enjoy algebraic expressions from now on, and hope that these training exercises were beneficial for you and to let you train more and more about solving and factorizing and expanding and finding the domain of definition of algebraic expressions.